Imagine, if you will, that you're trying to build a universe. You've got your blueprints, you've got your fundamental forces, and you've got a handful of subatomic particles like electrons and quarks. You put them all together, step back to admire your work, and then whoosh, everything flies apart at the speed of light. Your stars won't form, your planets won't stick, and you certainly don't exist to complain about it. Why? Because in your beautiful new universe, nothing has weight, nothing has mass. Everything is just zipping around like a caffeinated toddler in a bouncy castle. Welcome to What Is, and today we're diving into the subatomic mystery that explains why we aren't all just light-speed ghosts. We're talking about the Higgs boson, the so-called God particle, the most expensive secret in history, and the reason you actually have a shape. Before we smash some protons together, make sure to hit that subscribe button and ring the bell so you never miss a deep dive into the what is of our reality. To understand the Higgs, we have to travel back to the early 1960s. Physics was having a bit of a midlife crisis. Scientists had developed something called the Standard Model. It was a tidy little list of all the particles that make up the universe. It was elegant. It worked perfectly. Except for one tiny, glaring, universe-breaking problem. The math said that all these particles should be massless. Now in physics, massless doesn't mean light. It means that you have no choice but to travel at the speed of light. Forever. If an electron has no mass, it can't orbit a nucleus to form an atom. If there are no atoms, there's no chemistry. No chemistry, no coffee. No coffee, no civilization. The physicists were stuck. Their math was beautiful, but it described a universe that didn't look like ours. Enter Peter Higgs, a soft-spoken British theorist, along with Francois Englert, Robert Brout, and a few others. In 1964, they proposed a radical idea. What if the entire universe is filled with an invisible field? A sort of cosmic molasses that sticks to everything? They called it the Higgs Field. The idea was that particles don't just have mass as an intrinsic property. Instead, they gain mass by interacting with this field. Think of it like this. Imagine a crowded room at a Hollywood party. The room itself is the Higgs field. Now imagine a nobody, say me, walked into the room. Nobody knows me. I can zip through the crowd at top speed because no one stops to talk to me. I have very little mass in that environment. But now imagine Beyoncé walks into the room. Everyone crowds around her. They want autographs, selfies, a moment of her time. She can barely move. The field of people sticks to her, slowing her down. To the room, she effectively has a lot of mass. In this analogy, an electron is a minor celebrity, and the top quark, the heaviest known particle, is basically the Beatles in 1964. And a photon is the guy who's just there to fix the AC. He moves right through the crowd, totally ignored at the speed of light. But here was the catch. If this field existed, there had to be a way to prove it. According to the rules of quantum mechanics, every field has a corresponding particle. If you jiggle the field hard enough, a particle should pop out. That particle was the Higgs boson. For 40 years, it remained just a ghost on the chalkboard. A maybe. It was the missing puzzle piece of the universe, and without it, the whole picture of physics stayed blurry. By the 1980s and 90s, the hunt was on. But finding a Higgs boson isn't like finding a needle in a haystack. It's like finding a specific piece of hay that only exists for a billionth of a second inside a haystack that's currently exploding. To find it, we needed the biggest, most complex machine humanity had ever built. We needed the Large Hadron Collider, or the LHC. Built by CERN, the LHC is a 27-kilometer ring of superconducting magnets buried 100 meters under the border of France and Switzerland. It is, quite literally, the world's most expensive and high-stakes demolition derby. The plan was simple in theory, but terrifying in practice. Take two beams of protons, accelerate them to 99.99999999% the speed of light in opposite directions, and smash them into each other. The energy released in these collisions is meant to mimic the conditions of the universe just a fraction of a second after the Big Bang. At those energy levels, the Higgs field might just get jiggled enough to spit out a Higgs boson. But before the machine even got turned on, the world got a little nervous. You might remember the headlines from 2008. There were lawsuits. There were claims that the LHC would create a microscopic black hole that would swallow the Earth. Spoiler alert, it didn't. We're still here, mostly. The LHC was a triumph of engineering. It operated at temperatures colder than outer space, while the collisions created heat 100,000 times hotter than the center of the sun. It produces so much data that if you burned it all to CDs, the stack would reach the moon. For years, the scientists at CERN watched the data. They weren't looking for a flash or a bang. They were looking for a bump in the graph, a tiny deviation that suggested a particle with a specific mass was decaying into other particles in a way that nothing else could. The tension was insane. Every time the machine broke down, once due to a bird dropping a piece of baguette into an outdoor power substation, which is the most French way to delay the apocalypse ever, the world waited. Then came July 4th, 2012. Physicists from across the globe gathered in a lecture hall at CERN. Peter Higgs, then 83 years old, sat in the front row. The spokespeople for the two main experiments, CMS and Atlas, stood up to present their findings. They both showed the same thing, a bump. Right there at the 125 gigaelectron volt mark, they announced they had reached a 5 sigma level of certainty. In human terms, that means there's only 1 in 3.5 million chance that what they were seeing was a fluke. The room erupted. Peter Higgs pulled out a handkerchief and wiped his eyes. "It is an incredible thing that it has happened in my lifetime," he said. It was one of the greatest scientific achievements in human history. We had found the soul of mass. So, what does this mean for you, sitting there watching this video? First, it means the standard model is mostly correct. We finally understand why matter has substance. Without the Higgs boson, the atoms in your body would have no mass, and you would dissolve in a burst of radiation traveling at the speed of light. So thank a boson for your existence today. Second, let's address the God particle thing. Leon Lederman, a Nobel Prize-winning physicist, coined the term in a book title. Scientists generally hate it. Lederman actually wanted to call it the goddamn particle, because it was so hard to find, but his publisher wouldn't let him. So God particle it was. It doesn't prove anything about religion. It just proves that marketing is a powerful force of nature. But the discovery of the Higgs isn't the end of the story. In many ways, it's just a very expensive chapter 1. The Higgs boson we found is actually kind of weird. It's a little bit too light. In physics, being too light is a red flag. It suggests that there might be other particles out there, supersymmetric particles, that we haven't seen yet. Even crazier is the theory of vacuum decay. Some calculations suggest that the Higgs field might not be at its most stable state. It might be in what's called a metastable state. Imagine a ball sitting in a slight dip on the side of a mountain. It's stable for now, but if you give it a big enough poke, it could roll down to the very bottom of the valley. If our Higgs field rolls down to a lower energy state, it would create a bubble of new physics that would expand at the speed of light, incinerating everything in the universe and rewriting the laws of reality as it goes. There's no need to panic. The math says this won't likely happen for another 10 to the power of 100 years. You still have time to pay your taxes. Looking to the future, CERN is already planning for the Future Circular Collider, a machine 4 times bigger and significantly more powerful than the LHC. Why? Because the Higgs boson might be the portal to understanding dark matter. Dark matter makes up about 85% of the matter in the universe, but we can't see it, touch it, or detect it with normal instruments. But the Higgs boson interacts with mass, and dark matter has a lot of mass. The Higgs might be the bridge between the world we know and the dark universe we don't. We spent 50 years and billions of dollars trying to find one tiny flicker in a vacuum. Was it worth it? When people asked Robert Wilson, the first director of Fermilab, if their massive particle accelerator would help national defense, he said, "It has nothing to do directly with defending our country, except to help make it worth defending." The Higgs boson is a testament to human curiosity. We are a bunch of apes on a wet rock who decided we wanted to know why things are heavy. And then we built a 27-kilometer subterranean ring to find out. We found the grain of sand that gives the universe its weight. Now we just have to figure out what the rest of the beach looks like. If you enjoyed this journey into the subatomic, give this video a like and let us know in the comments what is one scientific mystery that keeps you up at night. Is it dark matter? Is it vacuum decay? Honestly, that one is starting to get to me. Thank you for watching What Is. Don't forget to subscribe for more deep dives into the big questions, all the small stuff, and the big stuff, and everything in between. We'll see you in the next one.